Okay, we're going to go through setting up a C440 with a C441. This is Eaton motor overload with an Ethernet adapter to it, so we can get a bunch of information from this device if we wanted to. In this particular situation, we're only doing the amps monitoring, but you can use it for a whole list of different device parameters. So let's go to the manual here, have that guy opened up. So before this, I went through and I set up the IP address, which is just a matter of flipping some dip switches on here, and then you can go to whatever the Ethernet, whatever address you put in. So in this particular situation, I flipped all the dip switches, and then I put in an address under network configuration of 192.168.70.15, and then this one is .3, 255.255.255.0. Comes standard with 192.168.1 dot whatever the switches on it are at. So you can read through the manual and set that up. It's pretty straightforward. And then after that, you set all the switches to a certain position and cycle power, and it should all take effect. And when you're dealing with these, anytime you change something, you should click to submit parameters, and then then you'll have to cycle power again if you change anything. So that's the hardware side. We're going to deal more with the communication side of things, because that's what took me forever to figure out. So we have a MicroLogix 1400 that we're using, and I have this all set up, so I'm going to kind of work backwards and then show you what I did and why I did and all that sort of good stuff. So we have the configuration, the channel configuration, and normally you'll have it'll be like this, right? So let's go offline first. Yes, yeah, and that's one thing too, is you can't edit anything about messages, or it appears anything in the rung of a message when you're online with it, with the processor. So that's kind of a good point that it made. So we'll go to channel 1, and then usually this is what we have, right? You put in your IP address, you disable boot P, disable DHCP, and then this is what you have. So general channel 1, channel 2, or general channel 0, 1, and 2. So if you click the MODBUS-TCP enable and you apply it, you'll see that another tab pops up. And then we don't need to change these. These are for if someone else is going to communicate with us via Modbus, and then we would put in which registers we want. Just make those end files like N20, 21, 22, 23, or whatever you want. And then the local port number TCP for Modbus, this seems to be always 502. Not quite sure why that is, but that's what it is. So we're all good here. And then you can see that I have some logic here. I just got a timer so that we're only reading messages every 5 seconds. And I have two of these Eaton setups, the C440 with a C441 on it, monitoring 2 different motors. So we'll go in here to setup screen, and as you can see, first I made a message register MG18. We can do that by you see it down here. This will record a bunch of information, whatever that stuff means. I don't really deal with it, but if you go here to the type and you go down, you can see message, and then you can make however many messages. You know, in this case I had to make it at least 2 elements, because I needed, obviously 2 motors to be monitored. But you can make it whatever you want. Oops, just delete that guy. Yes. So we go back in here, and we'll see. So this is our first message, MG18.0. Here you can configure it however you want. Once you check that Modbus mark, you'll be able to do the one integral MODBUS-TCP, and then we are going to do the out of all the options here, we're going to do the 3 read holding registers I'm not really familiar with the other registers right now, but you can see we have the familiar 40,000 for the Modbus. That's standard for all the registers in Modbus. So we're going to pick that guy. Then we choose the data table that we want to read the information into. In this case, I put it as N30 and 5 elements, and we're going to do 16 bits, so that's 1 word of data per. And you'll see that some of these parameters are double words. So I haven't really messed around with changing that yet. For what I'm doing for amps, it's just 1 word, so I'm good with that. So yeah, we'll see MB data address. We'll get that from the manual in a second. The unit identifier, not sure what that is, just left it at 255. Things worked. The routing information file, that's another one that we'll have to make. So you can come up here and click new. And if you go down here, you'll see routing information. And again, you can make as many of those as you want. And so I chose RI19, and then we have the Ethernet address of the device that we're talking to through Modbus, and then again port 502 because that's just what Modbus does. So we can close out of there. We'll see the second one. Did the same thing, pretty much exactly the same thing. I started at N3010 though instead of N30 because you can do that, and it's just a different IP address for the second one, and RI19.1, again port 502. So we have those, and then down here we want a watchdog as well, so I'm going to move a value of 5 into a certain register, and this register is usually, you can see here, it's the motor control state. It's usually 0 through 4, so every 5 seconds, if we're communicating properly, there will be a 0 through 4 that moves into here depending on the status of the motor. For this particular application, I'm not using that motor status, but you could obviously you want to move into a parameter that you're not using, because if you're using it, you move something to it, it can mess up your program logic. We have the reset, and then also I have an alarm that says if we have the value of 5 for more than 5 seconds, then we get a comms fault, and that makes sense. If the PLC itself moves a 5 into that register and something else doesn't replace it in 5 seconds, that means that it's not communicating. So, and we can also test this out when we go online with it, and I'll show you how we can test that in a second. So if we go back here, and we had MB data address 300. So how do we determine that? Well, I downloaded the data sheet for the C441. And then on this, it's going to list different devices. So we're going to scroll down. I believe it's page 40. And here you'll see that we are looking at, no, it's not page 40. 54. And here you'll see register definition for C440 overload relay. There's also different devices. If you scroll up, like this one, C441 motor insight, and it has a bunch of different stuff listed. So you got to make sure that we are looking at the proper device, because the C441 takes on the identity of whatever the first device it connects to. So if we go to RS links, we can see in here that we have, these are identified as C440s, even though we're connected technically to a C441 Ethernet module. So looking through here, I wanted to find the current. So I just went with the scale 3-phase average current right here. And number 304 is going to be the, it's going to be this data address that I need. So I started at 300 just for the heck of it, to take a few different words of information. And I mean, I could have just read the 304 for one word. In this case though, again, we needed something to test our watchdog against, in the sense it moves 0 through 4 into here. That's the only values it'll have. That presented itself as a a good parameter to use for Watchdog. So this situation, you see we start at 300, this guy right here, and then we're going to go 5 words, so 1, 2, 3, 4, 5, and we end up, the last word will be scaled 3-phase average current in amps. And you'll see the column headers up here. That register number is what I was basing this off of. Not really sure about the start coil. We didn't really dig into that too deeply. We could call Eaton, I guess, and ask them if we really wanted to, but all we need to know is that these register numbers are what we're looking at, and then you could write to it if you want to for certain registers, the name and description. So again, using the data sheet to determine all this, and we can go down and you can see everything that you can monitor with this particular device through Modbus. And that's how we got that. So now if we go to register N30, we can see I only put a few labels in, but you know, I labeled this guy what it actually is. The motor control state should be 0 through 4. That's going to change to 5. That's going to blink to 5, and then it should change back. And then we'll see that N34 is what I actually wanted the screw current reading. And then I made the other one N3014 is the mixer. So then I use those. I just put those directly on the screens here as N34. So it's just going to read from the device into the PLC and from the PLC into the screen directly. And that should be about it. I haven't actually connected a motor to this guy yet, so I don't know what kind of format we're going to get, if it's going to be, you know, just a rounded off integer of the amps, or it's going to be, you know, it's an integer file where it has an implied decimal somewhere, which, you know, we could just take whatever it gives us when we hook it up and scale it accordingly, multiply it, divide it, whatever we need to do in order to get the right format and pass it over to the screens. I might have to do a floating point instead of an integer, but that's no problem. So that's the basics of setting up Modbus for the C440/C441. And yeah, before this I tried for days to set up Ethernet IP CIP generic message. I can show you that real quick, even though you shouldn't use it. Let's see, MSG, blah, blah, blah. And we're going to go to integral. That's, you know, channel 1 is always Ethernet. And here we did the CIP generic. And then it gives you a whole bunch of options. So I set these up based on what I found in the manual and talking back and forth with Rockwell and Eaton, and just nothing was working. So Modbus is a lot easier. Just has a certain number of registers. You find which one you need and plug in the numbers. So that's how we got this one done.